Hello guys, today we are going to see one of the important critical aspect of production AI systems, which is autoscaling. Specifically, we will see an LLM based autoscaler, which is again a custom policy. So usually we know that the autoscaler typically adjusts the number of block replicas based on real-time demand, like the number of requests, the queue length, the total based on the total CPU capacity, things like that, right? So, so in production systems, autoscaling is an important, important feature which helps in maintaining the cost, maintaining the load thing, and for maintaining a scalable production system, right? So below here I'm in the sample diagram, I'm showing you a high level overview. So here if you see, we have this AIOS V1 policy rule. Again, all the policies in AIOS system, they follow a certain structure, which I will, I'll walk you through here as well. So we have this policy system in AIOS, with which we can actually create our own custom policies. So here, for example, in this tutorial, we are going to use the token-based load balancer. Rather than using the usual queue-based or latency-based or CPU-based things, we are using token-based load balancer to give an idea like how much customization we can do using the AIOS custom policies. So typically, okay, before if you want further information on different, what is the block autoscaler is about, you can refer this link. Here it covers where the autoscaler comes in a blocks life cycle, like where does it come and how to how the communications happen between different blocks, the controller and all, right? So you can check it here, and sample codes, the input or output structures are also actually available here. In case of upscale, we have to follow certain format. In case of downscale, we need to pass the instance list. So these details are available in this link. So in this tutorial, so as an overview, we will be going through how to build an autoscaler policy using the policy system of the AIOS, and we will also do some testing before we deploy it, like a unit test. Then we will deploy the policy. We will also see how to deploy the policy in AIOS. And then we will also simulate this, not a simulation, but we will also run it by an actual request, some concurrent request, so that we can understand visually. I'll show it in the KH logs also, how the scaling happens and how the scale down happens and what is the cooling period and all, right? Okay, now let's start with the basic understanding of what is AIOS policy system. So actually in AIOS, the policies are nothing but, it's like a quick function, a class file with certain requirements. We need to follow certain rules, which I'll share in a minute. And we can have our custom logics inside it. And we have to serve it in a certain format like function.py, and we need to pass certain requirements.txt files. So basically policies are pluggable versioned. We can have different versions of the policies also, and they are also reusable modules. So once you create a policy here, it can be used across different, any of the building blocks that we have, any of the blocks that we onboard. And if it is in registry, it will also be discoverable for many people. And also they allow us to customize how the AIOS manages resources, right? How to route traffic and all. So all these things can be controlled via the policy system, the AIOS. So if you remember in the first tutorial, when we basically created a block, we had a certain allocation.json file, which contained a chain of policies. So those are like, one is the access checker, which is like a policing system, which is embedded in the AIOS ecosystem to let's say we want our model to be run in certain zones only. I want this model to run in certain location of India, or I want this model to be run only in certain cluster. So those policies, like the restrictions, we can pass it to the access checker. Similarly, the cluster allocator, we can provide a suitable cluster that we want, or it can also understand based on the parameters that we provide which cluster to select. And similarly, resource allocator, I will also show in this tutorial. Actually, I will be assigning a certain cluster, and also as a resource, I will be saying you use this particular node and also this particular hardware. In this node, you use 0 and 1 GPUs, right? There's the GPU IDs that we typically use. And also we have load balancer to handle the request, to distribute the request. Similarly, we can have a stability checker to understand the health of the block, and we also have a autoscaler. So in this tutorial, we will be covering this autoscaler to understand how based on the load, the scale up is happening and how the scale down is happening. So for more details on the policy system, I request you to check this link. So in this policy system, we have various types. We typically have type 1, type 2, type 3 till type 5 we have. So the policies that we will be using in our tutorial is type 1, which is a policy that is loaded and executed within the AIOS application itself. So you can go through these this documentation. It will give you a comprehensive overview, and also the structure of the policies, what is the schema that we need to use. All the details are explained in this document. In this tutorial, we will see a sample implementation of this. So yeah, we are using type 1 policy. Let's forget that. Right. Okay, now let's move on to the actual policies details. So we are using something called a token-based autoscaler policy, right? So we could have shown this demo with something like a queue-based or a request-based autoscaling, but we thought since it's an LLM and the tokens related autoscaler could be a more interesting thing to show. So here we are we have a matrix which is already integrated into the model, and for more details on the metrics, we have some of the notebooks and tutorials. You can refer to that. And in this particular tutorial, we'll be using the input and output token metrics of the models. So which is, if you think about it, for LLM models, to maintain the cost, the replica, the GPU usage and all, this is under scaling based on the input and output tokens is an important and a good decision to maintain the cost, right? So that's why we are going to show this. So the logic of token-based autoscaling goes as 3 primary steps, I can say. Like if the rate of tokens per minute exceeds a certain high threshold, it indicates that the current number of replicas is struggling to keep up with the demand, right? So then to avoid any latency or performance degradation, then we will do a scale up, basically adding more replicas. But let's say after some time the load has been reduced, the peak hour has been crossed. Then if the token rate drops below a certain low threshold, then it means we have more resources than necessary. So then we will perform a scale down operation. Now again, it might be possible that this the transition between the scale up and scale down, if it happens so frequently, right, it can disturb the request. It can cause more latency to the end user. So because of that, and also to avoid any other discrepancies, we are having a cooldown period where we will make sure that the particular if we have done a scale up or a scale down event, then we will have a cooldown period before the autoscaler actions come into place. So that is the purpose of cooldown period. And so basically this approach will make sure that of course we have to adjust the thresholds accordingly, but this will give an idea about how we can provide a balance between the performance and the cost. And in AIOS v1 policy role, like if you refer to this particular document, you will come to know that it has certain structures here. The class structure, the init, the eval, the management functions. So these are some of the important structure that needs to be followed in for us to create a custom policy. So this is the first one is the init method in our class. So it will get a rule ID. For each policy, we will have a rule ID, and also the settings and parameters, right? So that it can initially set up the class with some state variables if required and all, right? So for that we have the policy, policy when we are registering, we'll pass some of the settings and parameters also. And then we have the eval, which is the actual logic where which is used for creating the actual logic where we can do the scaling up and scaling down or things like that, right? So it retrieves metrics, calculate average token rates, and decides whether to scale up, scale down, etc. And similarly, we have some of the management functions to handle some administrative commands. Let's say we want to override some activity in the autoscaler. Let's say we want to override the cooldown period. Let's say we want to override the minimum replicas or the maximum replicas. So we can do that via the management commands, right? So that's how the AIOS policy in short is structured to this is a high level overview. We'll go to some more details now. So this is the necessary imports that I need to do. Let me just run this. So now we have the init method. So here what I'm doing is basically I'm creating this class and having this init method. Here I'm passing the rule ID, the settings, parameters, and I'm calling this as I'm initializing the logger, and I'm setting initial parameter, the default parameters of input tokens up threshold. So we have this input token up threshold, which is the maximum input tokens that the model can, based on the capacity of our model and things like that, we can decide this number actually. But here I'm setting it 500 as a default value, so that if the number of input tokens per second increases more than this per minute across the instances, remember that a block can have multiple instances. So everything that the thresholds that we are discussing are the average threshold for the block, the average across all the instances for the block, right? So if the average exceeds the 500, then it means I need to do a scale up operation. If the average exceeds 300 for the output tokens generated per second, then it will do a scale up operation. So we can have a OR combination of these two, or a AND combination of these two, or a weighted combination. It's up to us, whatever logic we want. Similarly, I also have an input down threshold and output down threshold, which are set at 100 and 150 for the sake of this demo. And similarly, I also have min replicas, which is set to min replicas of 1 as a default. We can also have a max replicas. There is no harm in adding a max replica. Let me do that also. So I also have the max replicas to 2 and the average period. So all these metrics, they are in a running, they are in a rolling average, like 1 minute average, 5 minutes average, and 15 minutes average. So for the sake of the demo, I'm using average 1 minute, the rolling average 1 minute, so that we can see how the scaling up and scaling downs are happening within this time. I will also show in the metrics these different values of average 1 minute, 5 minute, 15 minutes as well. And we also have cooldown seconds, which I have set it the default value as 120 seconds. And also we are maintaining this state variable to understand when we can perform any scale up or scale down action, right? So let me run this. Yeah, so this is a now we will have a quick implementation of this cooldown method to avoid any frequent scaling up and scaling down, typically called flapping in the production language. So I'm checking if the last action is none, then I'm simply returning true because I want to immediately take that action, right? But if the last action is if the last action, the difference between the current time and the last action is greater than 120 seconds, then only I will do the actual scaling up or down, the autoscaler activity, or else I can simply wait till that cooling period. It is possible that in the cooling period, the thresholds or the metrics actual value, the live metrics values can change, right? That's the purpose also. So let me run this as well. Now let's move on to the eval method. Right. So here in the eval method only we will have all the necessary logics to perform the autoscaling operations. Like we can get the actual real metrics, the live metrics, latest metrics, and also we can perform the average input and output token calculation, and then the decision also can be taken here. So here you can see we are passing parameters, we are passing input data, and we are also passing certain context. So here I am first getting the metrics via the initial settings that we handled here when we are sending the in the init when we are assigning it in the init methods, and I am also getting the current instances that the block has, right, via this input data method, via the input data variable, and also in the metrics I'm selecting the block metrics, and basically all the required inputs are parsed here, and if there are no instances to process, right, if there is no live metrics or things like that, then there is no scaling decision, so it will simply return as no metrics found for the specified instances. But if in case, which is usually the case, like the metrics are always available, then we will add we will first fetch the input tokens per minute rolling and the output tokens per minute rolling, and we will aggregate it across all the instances of the block, right? Like we'll sum it across all the instances, so we'll get the total input tokens, total output tokens, and since we also know the total instance count here, we can average to get the average input tokens and average output tokens. Now based on this, we can take some decisions, right? So now let's say I mean here immediately I'm doing a cooldown method. If the cooldown is active, we can simply discard any scaling operations. But let's say the input tokens or the output tokens is so high beyond another threshold that we declare, then probably we can skip this cooldown method also, right? So that's the purpose of calculating this input tokens and average input tokens, average output tokens. If we are still in the cooldown method, cooldown time period, we can simply say skip is true, and the reason is cooldown active. And if the average input tokens, let's say, now we'll discuss the upscale logic. If the average input tokens is greater than the input threshold, we are doing an OR operation with, if the average output tokens is greater than the output threshold, then we will also check the maximum replicas, which is what we added just now. So if the instance count is more than max, more than or equal to the max replicas, probably we will skip any more scaling up. But if it's lesser than that, then we will note down the timestamp for the last action that we are taking, the last action timestamp, meaning the current timestamp, and we will return in this particular structure. We will say skip is false, the operation is upscale, and the instance count is 1, and the reason we can pass. We can also add a multiplier, like we can have instance count more than 1 based on the thresholds that we set for output threshold or the input threshold. Similarly, we also have a threshold for the downscale logic. If the average input tokens is less than the the input down threshold, and the average output tokens is less than the output down threshold, meaning we are making sure both the thresholds are lower, right? Then only we will perform a downscale operation. Again, during downscale, we need to check the min replicas parameter, because we don't want to make the system to scale to 0, right? So here it is scaled to 1. The minimum replicas value is 1. So we will check this particular condition, and we can note the timestamp again. And then so we can either take, let's say there are already some 5 replicas available, we can simply select one of them, or we can sort it, or we can come up with a logic here. So here we are taking the average tokens per minute rolling and using the output tokens per minute rolling to sort it basically, right? And then based on that, we are selecting the instances to be removed. Again, based on certain logic, we can have multiple instances to remove. That's why here in the output structure you can see the instance list that we are passing, it is a list, unlike the earlier scenario which is just a number, integer. So here we can, of course, the operation has to be downscaled. The instance list should contain the list of instances to be removed. And in case neither of them are required, we can simply say skip is true and no scaling action is required. Right. So let me run this. And we also have the management method. Management method, like I said earlier, here we are resetting the state variable. Like for some reason we want to interrupt and make sure the like there should not be any scale up or scale down period. There should not be any scale down or scale up happening. We can immediately reset the last action timestamp to be none. We can also handle another set of variables, like another set of actions to do certain other tasks, like increasing the threshold for this reset cooldown, or changing the min replicas or max replicas, like that. Right. So let me also run this. Now let's move on to testing this policy. So we have a basic implementation of this logic via the AIOS policy structure. The AIOS policy structure contains init method. It's our cooldown is just a helper method, but the AIOS policy should have this eval method and also a management function, right? So let's in the unit test, I'm just simulating different scenarios. Basically, I'm setting up the parameters that are required, the cooldown period, and I'm also setting up a scale up scenario, 600 and 200 here. I'm setting it manually so that the input tokens and output tokens per minute rolling are very high now, so that it can do a mock-up of scale up operation. Similarly, I have a mock-up for scale down operation and also a no action, because in the no action scenario, it should not unnecessarily scale up or scale down, right? That's the purpose. So let me run this unit test suite. It is important to have these kind of unit test and make sure the test code works properly, because then it will be easy for us to deploy it in the AIOS ecosystem, and so that things can run smoothly everywhere, right? That's the purpose of using the unit test here in the Jupyter notebook itself. So as you can see, there are no errors and all the tests are successfully passed. The scaling up test, it has passed the scaling up. The scale down method test, it has passed the scaling down as well. And in the no action also, it is not doing any action. So basically it has passed the test. So now we can go ahead and deploy the policy. So in AIOS, if you want to deploy our custom policy, we have certain steps. Okay, I'll be briefing these steps now, and this holds true for any of the policies that you come across in AIOS ecosystem. So there are typically three main steps. First of all, we need to assemble the policy, right? First of all, we need to assemble the policy. Then we need to upload the policy to a certain location so that the AIOS ecosystem understands that there is a policy here and which policy to refer to for a given policy name. And also we need to register the policy. Now I will go through one by one. So in the initial assembling stage, basically we need to create a code folder, and in that code folder, whatever function that we have created, the class file that we have created here, right? So this has to go into that particular this full class file, right? The eval method, the init method, the cooldown period method, and also the management method. All these should come into a single file called function.py, and also we need to have a requirements.txt so that the necessary libraries are installed during its live runtime instance of the policy. So here you can see I'm creating the request library, adding the request library to the requirements file, and we already have this function.py. I have already implemented, added it in this notebook, right? So if you can see here, there is a code folder, right? In the code folder, I have the function.py and the requirements.txt. So let me run this. So it is basically just displaying that for us, whatever is there in the function.py. You can see we have also added the max replicas, which I have kept added already as a function.py file. And yeah, before that, let me just remind you, since we are using a Jupyter notebook, I am redeclaring the class definition here and associating that particular method. In case of a single function.py, this will not be required, as we will be simply keeping the methods, necessary methods only. So yeah, now I will do a zipping and creating a zip file named tokenautoscaler, right? And I am zipping the entire code folder. Yeah, now it has created a zip file. Probably these things we need not worry for now. And I'm going to upload. Now we have done with the assembling the policy. Now we are going to upload this to a policy package endpoint. So we have this endpoint and I upload a endpoint, and I'm passing this particular tokenautoscaler.zip as a file name, and the path is the same path as the Jupyter notebook. So let me run this. Yeah, so it will get saved in this particular location, right? So now we are done with the uploading the policy package. Now let's move on to registering this policy. So here again we have a certain endpoint, certain structure to follow. For more details, you can refer the first document I have shared as well, the policies in the AIOS. So this link, the policies system overview. This will give you the schema, input settings, those kind of things. Here I will show a sample scenario for this particular policy that we are implementing. So here I'm basically, we can also run this via curl request, but here I'm just demonstrating with the Python's request package. So here we are declaring the name, version, and release tag. Tokenautoscaler 2.2 version is release tag is stable. You can have our own names and other things. And most importantly, this is the path that we need to provide. So here we uploaded to a certain path, right? Here all the files are the policies are uploaded to certain path. So that is what I'm passing here. In this particular endpoint is what things are getting saved, the zip files. So I'm giving the name also tokenautoscaler.zip, right? And we are also describing the input schema. So in the input object, input data that we are using, we have this current instances variable, right? And it's an array, so I'm passing the type as array. Similarly, we have certain structure in the output schema as a skip operation, instances count, list, and all, right? So that also we are declaring its type and the possible values. Similarly, we also have the settings schema, where we already have some of the settings like get metrics and all. And in the parameters that we discussed, like the input token subthreshold, the output token subthreshold. So these are some of the schema that we are providing to the policy when we are doing a registration, right? So the whole thing is about registration. Excuse me. And we can also pass the actual values. So here we are passing the minimum, maximum ranges and all we can pass, the allowed types and all we can pass. Here we are also passing the actual values, some of the default values that we can use, right? And a description. So in case some of these things are used during any discovery stages and all in future, so this descriptions will play an important role. And this policy payload that I've basically I've assigned to this variable, and I'm calling this particular endpoint, the policy endpoint, to register it, right? So all we are doing now, we have done is we have assembled the policy. Now and then we have zipped the policy to a zip file and called it tokenautoscaler.zip, and now we are registering. So let me run this cell. Yeah, now you can see policy is created successfully, and the response is true, right? Okay. Now let's move on to triggering and observing the actual autoscaler so that we can see how it works in action. So note here the model that I'm going to show a demo. I'm just giving an input in case you are using the same Jupyter notebook. So here we are using a Gemma 3 27 billion 8-bit model, and it is distributed across two A100 GPUs, which I'll show also. And basically, we did a preliminary benchmark, and in that we are getting close to 25 to 30 output tokens per second. So in case you are using this, you can adjust the thresholds accordingly, so that you can try out your own custom policies. So yeah, now let's just recall one thing. During our creation block time, right, when we are creating the block after onboarding, so we had this particular allocation.json. So if you remember, we created a Gemma 3 27V block 2, and we registered this particular LLM model, and then we created this allocation file. So here, if you see, we have several policies that I was talking about initially, like the cluster allocator, resource allocator, and all. So let me scroll down to show the current parameters that I have set. So I have set we are passing this particular version of the tokenautoscaler, which is what I initially this is the version name, right? The tokenautoscaler 2.0 stable. So this is what I've already added and kept it here, the tokenautoscaler 2.0 stable as the policy URI. And we also have the input token sub threshold. I modified it to 400, and this is 200, and the down thresholds are 150. And for now, for the demo sake, I'm using the average period of average 1 minute. Okay. So now let's move on to actually deploying this block. The model is not deployed, so let me run this to deploy it again. So it's saying the task is scheduled in the background. So yeah, while it is getting deployed, let me also understand how we are. Let me also give a brief about how we are gonna test this. So I have this client code which will perform concurrent request to the model. Since we have kept a threshold of 400 and 200 as the input and output token scale up threshold. What I'll do is the default the input tokens I have set it to 300, and I'm generating different requests. The text will be different, and I'm saying that it at max the generation config for the model. I'm saying at max it should generate only 128 tokens for per response, right? So, and I'm also calling totally some 10 requests concurrently. So to understand how to see these logs and how the actual autoscaler and all happening, let me open the KH dashboard that we have here, so that we can understand, we can check the logs and understand how things are working. Let me create the token that I need to log in. Yeah, now I have the KH dashboard with me. Here, if you go and click on blocks, right, now you can see the Gemma model is ready, it is deployed. We also have the corresponding executor ready. So let me open this in the different tabs. So we have this here. Let me select the instance and keep it. The model is loaded. You can see that it is available for serving, and also let me keep the autoscaler logs. Currently it is saying the skip is true and there is no scaling action is required. Okay, now let's proceed towards actual testing of this autoscaler. So I will be running this with the maximum number of requests of 10. We'll see what happens there. So I'm running this. So it is saying it is started testing with 10 concurrent requests, and each request will have 300 input tokens and ask for maximum 128 output tokens, which is what we have passed. Excuse me. So here you can see the session ID is also getting printed, and the latency it takes to complete one full request. So let me show the logs that we are receiving. Yeah, so here you can see, so initially this matrix gets updated every 30 seconds. So here at this point of time, it is saying the average input tokens are 0. It should increase in, yeah, actually it has already, okay, I think the request starts here. Yeah. So initially it was 0. The input metrics are all 0. Since I started bombarding with more requests, you can see the average input token got increased to 590. But as per our threshold, it should be 400. And the average output threshold is 200. But we have used an OR operation. So if either the input tokens or the output tokens increases, then this will happen. Then the scaling up will happen. So now the scaling up has started. That's why it is created one more instance. Let me just to maintain the load. Let me run continuously so that I can show it in the demo as well. So here you can see that this particular instance got created again, right? So if I open the logs of this, you can see that it will also start getting the requests here, right? So it has started receiving requests. It is generating the outputs also actually. So in the autoscaler, if you see, it has basically created another instance, and post that, if you notice here, so the average input tokens, right? It started averaging it out. Like since there are two instances now, earlier during when there is only one instance, the input tokens are very high, right? So let's say even if my model can accept it, but since I have set the threshold as 400 as a safety margin, so it started doing an upscale operation, and then the average input token is getting maintained again, right? The 294 tokens per second, meaning it is processing, it is distributing across the two instances also. So you can see this is one instance that I have here. This is also in processing stage, and this is also in processing stage, right? And again, just to maintain the load, let me run the request continuously. So here, it was maintaining it, and then I'm again bombarding with the maximum. Since I'm continuously hitting to maintain the load, I'm still continuously hitting it. But this time it has correctly set the maximum replicas is 2 only. That's what I have kept it as a default value. And because of that, it is not allowing any more replicas, right? So then what will happen? It will start queuing things. So that also can be seen. And it is everywhere, you can see the average input tokens is also getting maintained. And if it so happens that we are giving more requests and our model can still take more input tokens per second, then it is still possible to get a higher values. But initially we got some 600 and all very big numbers, so that at least will not happen now. So after some time we can also see a scale down operation, right? So here we are also just for the sake of understanding, we are printing the average queue length and all. So currently it has one task in its queue. What is the average queue length that is available in 1 minute, 15 minutes, and 5 minutes again? And if I just scroll and show some of the other logs, you can see that in between stages, when the cooldown is active, it is not doing any scale up or scale down operations, right? It is also saying cooldown is active. So it is simply discarding any other checks and proceeding to simply returning with the skip through, right? So here it was the scale down, scale up method getting called. Now we should see in some time that the scale down should get triggered as well. So here again, just to show, we also have requests getting processed in both the instance. This is one instance. This is the other instance, right? So here it has processed everything. So I think the scale down should get triggered in short time. Yeah, now it has moved from the scaling up scenario. It was trying to scale up again since we have given maximum replicas as 2. It was not scaling. Now it is going to the no scaling action required scenario because the average input tokens is now again 295, which is less than the threshold that we have set. So we can look for the scale down operation. Yeah, now you can see the scale down operation is triggered. You can see it is removed. You can see that it is it has selected this particular in SFUT as the instance to be scaled down. Now in some time, right, it didn't proceed and it didn't do another scale down because it will touch the minimum replica. But before that, there is also a cooldown period which it will try to avoid any autoscaler operations, right? So this concludes our tutorial on autoscaler. I request you guys to try out your own custom policies for this particular autoscaler. This token based, the input and output scaling is just a just a sample custom policy that we have created. But of course, it will be better than the plain request based scaling because in LLM world, we need to understand the tokens usage, right? So we request you to try out, more different complex policies, try out different weighting policies maybe. Because in case of complex document analysis workflows and all, we can see that this kind of scaling logics are important and we can have our own different versions as well, right? See you in the next tutorial.